3.6 topics in theory of polynomial functions. So first they want you to find what they call the intermediate value theorem. So the way to do that, the instructions will say, show the function has a real zero between the two numbers given. So they give you 2 and 3, and all you're going to do is plug them in. So let's start with p of 2. 2 cubed minus, 2 cubed, make sure you do parentheses, minus 2 times 2 squared minus 2 plus 1. This gets you 8 minus 2 squared is 4 times 2 is 8 minus 2 plus 1, which gets you negative 1. So p of 2 is equal to negative 1. Let's try p of 3. P of 3 is equal to 3 cubed minus 2 times 3 squared minus 3 plus 1. Okay, 3 cubed. 3 times 3 is 9 times 3 is 27. Minus 3 squared is 9 times 2 is 18. Minus 3 plus 1. This will get you 7. So p of 3 is equal to 7. Okay, so here's how you know whether the function has real zeros between the two. Okay, we call 2 and 3 consecutive numbers because they're right after each other. And if you were to graph this, okay, and you would see a table, right? You would see x and y values. Every time you see a sign change, that means that there's a real zero between. So if we were to look at this as a table, 2 got us negative 1, and then when we plugged 3 in, that got us 7. Because there's a sign change, because this one is negative and 7 is positive, then the answer for here is yes. Yes, there's real zeros between the two numbers. And again, why? Because of the sign change. We have consecutive numbers and there's a sign change between the two consecutive numbers. So our answer is yes, there's real zero between 2 and 3. All right, the other way we find zeros is using synthetic division. This should be a pretty good review for us. Now remember, we're going to set up the box, and the number that goes into the box is the dividend, the one on the bottom. We set that equal to 0. So x is equal to negative 2. That is the number that goes in the box. Then you use your coefficients. So 5, negative 6, negative 28, and 8. We drop the first number down, and then from there, we come this way and we're multiplying to get us negative 10. And then we add down to get us negative 16. Okay, again, should be a big review for us here. So 2 times 16 is 32. Okay, and that's a positive 32. So 32 minus 28 is 4. Negative 2 times 4 is negative 8. 8 minus 8 is 0. Okay, so here's our answer. Let me change colors. Because our equation started with x cubed, which is right here, to get our answer, you knock it down 1 degree, which is x squared. So if this is 5x squared, the next thing after x squared is x, and then you have your constant. So our answer is 5x squared minus 16x plus 4. That is our answer. Okay, let's look at the next one. So what number goes in our box? Well, x minus 3 equals 0, so x is equal to 3. That's the number that goes in our box. Notice here, it goes 3x cubed. We're missing the x squared, so we need to do 0, minus 2 plus 5. All right, drop that 3 down and begin multiplying. 3 times 3 is 9. That gets you 9. 3 times 9 is 27. This gets you 25. 3 times 25 is 75. And this gets us 80. Okay, remember that number in the box, we call this our remainder. So here's how you're going to write the answer. We started with x cubed, so this is x cubed, right? And we go down 1 to x squared. And then after x squared is x. So here's our answer. 3x squared plus 9x plus 25 plus 80 over your dividend, which is x minus 3. If you forget the remainder part, it would be wrong. Okay, so we have to have that remainder part in there. Okay, here's another way to find, so this says find the remainder. So this is exactly like the examples we did up above, where we're able to find our remainder using synthetic division. So when it wants you to find the remainder and it's already written as p is -2, that's the number that goes in your box, -2. There's no solving on it. Okay, then the coefficients. -1, we're missing x cubed, so that's 0. 3, -4, -5. Okay, we drop this down, -1. So 2, we're doing it differently. 2, remember you're multiplying. 2, 2, -4, add down, -1, 2, -2, 4, and -1. This is my remainder. So if we're trying to find the remainder, the way you answer is p of -2 is equal to -1. So what we could have done at the very top of our example, if I were to put 2 and do a synthetic division, I would still get -1. Let me show you. So if I don't plug it in like the old-fashioned way, and I do synthetic division, that would mean 2 would go in my box. I would have 1, -2, -1, and 1. Drop the 1 down. That gets me 2, 0, 0, -1, -2, -1. So my remainder, if I would use the remainder theorem, p of 2 would equal to my remainder, -1, and that's what we got before. So that's how it all connects. Okay, they're going to ask you, is the number a 0 or is the number a factor or the dividend? So if we would look at A, is -2 going to be a 0 or a factor? It means the same thing. So they're telling you to put -2 in the box. And this one's 3/2. Yes, I know it's fractions. Keep going. -1, 3/2, and then we're missing that 0 out there. So 3/2. Okay, you're going to multiply here. So this gets you a -3, which is -4. Okay. This gets you -8. Nope, +8, I'm sorry. So if I need to, I should change that 8 into a fraction. So it's 16/2. So that gives you 19/2. And then -2 times that gets you a -19. I'm going to cancel that over a time. And you add down to make -19. So is -2 a 0 or a factor of this equation? And the answer is no. And why is the answer no? Well, I wrote it right here. The remainder must be equal to 0 to say yes, that it's a factor of 0. Okay, let's try this next one. So it's saying that, it divide this divided by x plus 2. So the x plus 2 goes in your box, minus 2. Okay, and then you write it out. So 4, 24, 48, and 32. You always want to check to make sure. 3, 2, 1, 0. So you're good. 4. Okay, so negative 8. So 24 minus 8 is 16. 16 times 2 is a negative 32. Okay, so 48 minus 32 is 16. And then 16 times 2 again is 32. This time it's negative 32. So my answer is 0. Okay, so is x plus 2 a 0 or a factor of this equation? And the answer is yes. And why is it yes? Because your remainder is equal to 0. Okay, dividing polynomials, this is very back to basics. Just want to make sure you know how to do it. When you have a monomial, when you only have one term at the bottom, okay, it gets distributed to both. So it really looks like 2x to the 6th over 2x plus 3x cubed over 2x. And then you're going to simplify those. So the 2's cancel. This x goes up here and reduces that down to x to the 5th. The 3 and the 2 will stay there. This x, well, you bring it up, right? You subtract by 1, so that's x squared. So my answer is x to the 5th is all that's left on the left side, plus 3 halves x squared. Okay, then they ask you to do long division. So long division we're doing in class together. But these are the notes for 3.6.